Hi, I'm Erik Linask. I'm here at Interop with Carmin Caferra from BVS. Carmin, thanks for joining me.
You're welcome.
Let's get right to it, I guess. You've got one of your your test devices here with us. Tell me about it, and I guess most importantly, its relevance to the folks here at Interop.
We've brought along our Yellow Jacket tablet for Wi-Fi analysis. It's our flagship Wi-Fi test tool. It will support 802.11b, a, n, and g testing of the networks. And we're trying to educate people a little bit here at the show regarding 802.11n and what needs to be specifically tested regarding that particular protocol since its recent ratification back on September 11th by the IEEE. What we've found and seen over the past few years, even with the draft spec, is that most people are seduced by the high data rates, 100 megabit per second plus, from an 802.11n access point. It's not that easy to get, however, especially when it's mixed in at the 2.4 gigahertz range with 802.11b or g. A little easier to do up at 5 gigahertz. This instrument provides windows on the radio frequency physical layer environment. And what we encourage people to do with this is to take it, do radio frequency spectrum analysis to check and see if they have any interference on co-located channels, because the multiple input, multiple output capabilities of 802.11n would require a 40 megahertz bandwidth rather than 20 megahertz bandwidth. And then once that's established, it also has the capabilities to verify the settings of the access points, the parameter settings that they're set up with before they're deployed. Those things are very important in order to get the maximum bit rate out of it.
So is the recent ratification of the 802.11 standard and sort of the move towards N technologies, are folks having a difficult time understanding that they need to do some different things regarding testing around it?
Actually, they have been using our tools when they deployed 802.11b, G, A networks, etc. The unique thing about N is the multiple input, multiple output configurations for parallel data streams. But there's also a stress on bandwidth as well. And it's even more critical now to check for interference on the frequency band, the availability of adjacent channels, which is best done up at 5 gigahertz because each channel is independent of the other. Down at 2.4 gigahertz, they're only separated by 5 megahertz, so there's plenty of overlap there. As well as there's more to set up with an 802.11n access point as far as its configuration is concerned. There's a few other settings that need to be checked. You know, it's one thing to hook it up to your desktop, load it up with the parameters and deploy it. But before everything gets really busy, an independent, autonomous way of checking it over the air helps in finding the problems before the network is turnkeyed and running.
Why not just, like, say, set it up, get it going, and sort of do it by trial and error?
Good question, except there'd be a lot of disappointment there in that you know, an enterprise may have played a little extra for 802.11n capability, and then if they've ignored all of the upfront work, they'll be disappointed in that their data rates that they wish they could have achieved won't be happening. And so they'll have to come back and do it later on. It's probably a lot easier just to take care of those things up front. But the tool is ready either at the front end or at the back end of the deployment, regardless.
How are you going to market with the device?
Well, we've seen the price of 802.11n access points and interface devices start coming down. And so there's more of a demand. Our phone has been ringing about, hey, do you have anything that we can use to test for 802.11n? We've already been approached by several universities that are trying to completely launch 802.11n only for their services within the educational system. And you know, slowly it's being adopted by our enterprise clients. The U.S. government is already starting, and we also have them as a client of ours. So I think the fact that the spec has been recently ratified and everybody's more comfortable because they're not going to buy a draft device to the spec, but actually the ratified, there's more of adoption there. The fact that the prices are coming down absolutely helps. because over a year ago, the price of an 802.11n draft setup was much more expensive than a BG or an A. You know.
Is it's a mass market adoption of 802.11n access points going to have to wait until a lot of the B and G endpoints have sort of outlived their useful life?
Well, the standard provides that they will live together with B and BG devices in the 2.4 gigahertz space. However, the presence of any of those other devices along with N will scale down the megabit per second capability of the network. Up at 802.11a, it's easier to deploy, and that's where we're seeing more people buy networking hardware and deploying. It's a lot easier. There are more channels. They're full 20 megahertz channels. It's easier to move channels around. There's less interference up at 5 gigahertz. And it's a lot easier to pair up two channels for a 40 megahertz bandwidth. So I see our instruments being used a lot more to do deployments for 802.11n up at 5 gigahertz. But I also see our instrument being used heavily to try and troubleshoot down at 2.4 gigahertz for those people that are trying to clear out the legacy devices, B and BG, and just stick with N. That's a little tougher to do, though.
Excellent. Thanks, Carmin. We've been talking here at Interop in New York with Carmin Caferra from BVS. Again, once again, thanks for joining us. Have a great rest of the show.
You're very welcome.